This is an example from MGF 1107 when we are converting a numeral in a different base to a numeral in base 10. The given example here is in base 2, and recall in base 2 there are only two digits in base 2. The two digits would be 0 and 1. Those are the two digits in base 2. Now also recall in base 2 we have different place values. Unlike a base 10 system where our place values on the right would be 1 and then 10 and then 10 squared, which is 100, and then 1,000 and so on. The place values in base 2 from the right would be the ones, and then here we have the groups of 2. Here we have the groups of 2 squared, which is 4s. Here we have the place value of 2 to the third, which is 8, and then 2 to the fourth, which is 16, 2 to the fifth, which is 32, 2 to the sixth, which is 64, and then 128 and 256 and so on. So again, those are the place values. So very much like we have in base 10, the Hindu Arabic numeral, we have the ones, the tens, the 10 squareds, which are hundreds, and so forth. Well, in base 2, they have different bases. So let me erase the base 10 down there. So again, these are place values, or some people call them positional values. So looking at our example, from the right, we have 0 ones, we have 0 ones, we have 1 2, we have no groups of 4, we have one group of 8, we have one group of 16, and we have one group of 32. So all we have to do is multiply the digit that is in the place value times the value of the place value, and that's how we convert to base 10. So to convert to base 10, we multiply. So you can either start on the left or the right, just be very careful what you multiply by. I'll start on the right. So that means we have 0 in the ones digit, so it's 0 times 1, which is just going to be 0, plus we have 1 in the 2 place value. There's a 1 that's in the place value of 2, so it's 1 times 2, plus 0 times 2 squared, which is 4, plus, I'm dealing with that 1 right now, 1 times the position value of 8, plus 1 times the position value of 16, plus the last one is in the 32 place value. So in our problem, it looks like we only had that many digits. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yep. So we didn't need these larger place values because there were no digits out there. Now we just multiply and add them together, and that would be the equivalent base 10 numeral. So we have 0 there, plus 2, plus 0, plus 1 times 8 is 8, plus 1 times 16 is 16, plus one group of 32. And if we add those up from left to right, we have 2 plus 8 is 10, 10 plus 16 is 26, and 26 plus 32 is 58. So 58 is the base 10 numeral. So 1 1 1 0 1 0 in base 2 is equivalent to 58 in base 10.